My presentation today describes favourable changes in biomarkers of potential harm when switching from cigarette smoking to using a tobacco heating product for 6 months. At last year's third Scientific Summit on Tobacco Harm Reduction, I presented our 6-month biomarker of exposure results from our study on British American Tobacco's tobacco heating product, Glow, demonstrating that, compared to continued smoking, switching to Glow completely resulted in a statistically significant reduction in exposure to a range of toxicants classified by the United States Food and Drug Administration as respiratory, cardiovascular, reproductive, and developmental toxicants and carcinogens. That most of these markers assessed reached levels similar to complete cessation, that the reductions were rapid and sustained for the 6-month period, concluding that these findings support Glow as a reduced exposure tobacco product. Today, I will share with you the biomarker of potential harm results over the same 6-month period. In terms of study design, this was an ambulatory switching study carried out to the international standards of good clinical practice at 4 clinical sites in the United Kingdom. The study was registered on the ISRCTN database, and the protocol was published in full in a peer-reviewed journal with the reference shown here on the slide.
Well,
in brief,
in
3 separate populations were recruited. Up to 280 smokers with no intent to quit, with up to 80 of those randomized to continue smoking, and up to 200 to switch to using Glow. 190 smokers intending to quit were supported in doing so with smoking cessation counselling and the option to use nicotine replacement therapy or pharmacological nicotine cessation therapy. 40 never smokers were also recruited to continue not to smoke. Participants attended the clinic approximately every 30 days for 1 year, though the never smokers were requested to attend less frequently. Breath, blood and urine were analysed for a range of exposure and effect biomarkers, and physiological questionnaire and safety measures were also performed. Whilst the 12-month clinical phase valve study is complete, my presentation today is focused on the biomarker of potential harm results over the first 6 months of the study, visits 1 to 7, as indicated in the red box here. An assessment of medium to long-term compliance with smoking abstinence within the Glow and cessation arms was absolutely key in order to avoid potential underreporting of the effects cessation or switching to Glow has on the study endpoints. Traditional, short-term measures such as expired carbon monoxide would not be appropriate, as they only detect very recent smoking, whereas there were at least 30 days between visits in our study. Specific for tobacco smoke exposure, we used a hemoglobin adduct, which we abbreviate to CVAL, as a long-term biomarker of compliance in our study. Based on the life cycle of red blood cells, CVAL from cigarette smoking is detectable in the blood for approximately 90 to 120 days. Based on CVAL levels seen in our previous clinical study of a reduced toxicant prototype cigarette, we set thresholds for CVAL levels at 3 months, 6 months, and 12 months in this study, and use these to categorize subjects in terms of their compliance with not smoking. This was pre-specified in our statistical analysis plan, which has also been published in a peer-reviewed journal. This table provides an overview of participant numbers. The total enrolled column shows the number of participants we enrolled into each study arm, with the next column showing our target for the number of compliant completers of the full 12 months. The next 2 columns show the numbers who reached the 6-month time point and the number of withdrawals. Withdrawals include those who self-withdrew or were withdrawn from the study prior to 6 months for any reason. As you can see, the number completing to 6 months exceeded our target for each arm. This second table shows the number of participants who were compliant with the cigarette smoking restrictions in the Glow and cessation arms based on pre-specified levels of CVAL in their blood. With solus use or complete smoking cessation in the region of 75%, we still exceeded our target number of compliant completers. We assessed a range of biomarkers of potential harm indicative of several early biological effects, functional changes, and symptoms which are associated with smoking-related disease progression. These diseases include cardiovascular disease, CVD, cancers, and lung or respiratory diseases such as chronic obstructive pulmonary disease, COPD. Whilst NNAL is a biomarker of exposure for the tobacco carcinogen NNK, urinary levels of NNAL are also considered a biomarker for lung cancer risk. In our study, we assessed changes from baseline for each of these markers in the group of participants who switched to Glo and compared those changes to those in participants who continued to smoke. Now to share with you some results. The graph on the left here shows the mean average changes from baseline at 6 months in urinary 8-epiprostaglandin F2 alpha. This is a compound produced by the body through oxidative stress, a process implicated in several smoking-related diseases, including cardiovascular disease, cancer, and lung disease such as COPD. Similarly, on the right-hand graph, mean average changes from baseline in white blood cell count are shown. Raised white blood cell counts are indicative of general inflammation, playing a role in cardiovascular disease and carcinogenesis, with elevated levels also correlating to risk of COPD exacerbations. For both of these markers, our results following a 6-month switch to Glo, the orange bars, show a marked reduction from baseline, which is statistically significant compared to those who continued smoking, depicted by the blue bars. The markers shown in these two graphs are indicators of bronchodilation and lung health. The orange bar on the left-hand graph shows that there was a mean increase in the concentration of nitric oxide measured in the breath of participants who had switched to Glo for 6 months. Levels in this group of participants and in the group who quit tobacco use, shown by the grey bar, increased towards levels expected in people who have never smoked, whereas the blue bar shows that there was no change in those participants who continued to smoke. On the right-hand graph, the blue bar represents continued smoking, showing that the volume of air which participants could force from their lungs in 1 second at baseline had reduced by the 6-month time point. The grey and orange bars, which show participants who quit tobacco use and participants who switched to Glo, respectively, do not show this detrimental effect on the lungs. Raised concentrations of 11-DTX-B2, a breakdown product of a major thromboxane which induces blood clotting and arterial constriction, are a risk factor for cardiovascular disease. As indicated by the grey and orange bars in the left-hand graph, our results show similar reductions in the mean concentration of this marker in participants who quit tobacco use completely or switched to Glo for 6 months. High-density lipoprotein, or HDL, which is sometimes referred to as good cholesterol, has athero- and cardioprotective properties in helping remove other harmful lipids from the cardiovascular system. Even small increases in levels of HDL are associated with reductions in cardiovascular disease incidence. Our results, in the graph on the right, show an increase in levels of this marker after 6 months of smoking cessation or switching to Glo. CYCAM1 is found in blood plasma as a result of white blood cells attaching to dysfunctional or damaged endothelial cells. Elevated levels of CYCAM1 are observed during inflammation and early atherogenesis and are predictive of cardiovascular disease risk. As indicated by the grey and orange bars in the left-hand graph, our results show reductions in the mean concentration of this marker in participants who quit tobacco use completely or switched to Glo for 6 months, whereas the blue bar shows an increase in the mean concentration of this marker in subjects who continued to smoke for the same period. On the right-hand graph are our results for NNAL. This is a biomarker of exposure to the tobacco-specific nitrosamine NNK, and in last year's presentation, I described how exposure to NNK was statistically significantly reduced by 3 months after switching from smoking to using Glo, compared to those who continued to smoke. But NNAL is also a potent carcinogen in its own right. urinary NNAL levels have been shown to be higher in smokers who develop lung cancer than in those who do not. Our results show that following a 6-month switch to Glo, urinary NNAL levels were greatly reduced, shown by the orange bar, compared to those in subjects who continue to smoke, depicted by the blue bar. In summary, switching to Glo resulted in statistically significant changes in several BOPHs compared to continued smoking. The difference was significant at 6 months for AEP-PGF, white blood cell count, and nitric oxide. For NNAL, the difference was significant when assessed at 3 months and was thus not statistically reassessed at 6 months, but the reduction was maintained for the 6-month period. For the majority of the markers, the effect size was similar to that seen for smoking cessation. Though not included in the formal statistical assessments, favourable directional trends in SICAM-1, HDL, and FEV1 were also seen in Glo switchers, with unfavourable trends in continued smokers. This meets the standard, and arguably the gold standard in terms of similarity to cessation, proposed by the United States Institute of Medicine in their 2012 report on scientific standards for studies on modified risk tobacco products. Along with the findings for biomarkers of exposure, these data strongly suggest that the negative health impacts of cigarette smoking may be reduced in smokers who completely switch to using Glo. Before I finish, I'd like to mention that the 6-month findings from our study were published earlier this year in the journal Internal and Emergency Medicine in their topical collection titled Health Impact of Electronic Cigarettes and Tobacco Heating Systems. I would like to thank my co-authors, and we would like to thank Covance, Richmond Pharmacology, Solarian, and Simbec for their management and conduct of the clinical phase of the study, and Covance, Solarian, and ABF for performing the bioanalysis. I also thank the session chairs and the conference hosts, organisers, and committees for allowing me to speak, and I thank you all for your attention.